Hi, in this video we're going to discuss recurrent neural networks. Previously, you looked at how embedding layers can be used to help map words in a sentiment model. Words found in positive reviews were on one side of the graph and negative reviews on the other, and ambiguous words were put in someplace in the middle. For example, using training data like this, you can see how the model may start associating words like great and enjoy with positive reviews and didn't with negative reviews. But what about this review? We can see that it's clearly positive, but it uses some words that will likely be associated with negative reviews, such as nothing and wrong. By themselves, the words can send mixed signals, but when looked at in the context of the rest of the review, they are actually positive. This is where recurrent neural networks come in. A recurrent neural network, or RNN for short, is a form of a neural network that uses a feedback loop to help memorize previous inputs. A recurrent neural network uses long-term and short-term memory components to remember parts of the input so that it can be used further down. Essentially, what this is doing is remembering words from earlier in the sentence and applying them to words later in the sentence. We will always use a bidirectional layer with the RNN model. This allows you to use feedback from earlier words on the later words, but also the impact from later words on earlier words. RNN models are useful to help associate words together. For example, this review has two negative words and a positive word at the end. Using a recurrent neural network, the double negative can be associated with the positive word later, and the model is able to evaluate this as a positive review despite the negative words. While RNN models may seem a little hard to understand, they are actually easy to implement and nearly identical to the embedding models. You can understand what they are used for and how to implement them, even if you fully don't understand how they work. If we start with the embedding model you saw previously, the only change is to remove the flattening layer and replace it with a bidirectional LSTM layer. This is actually two layers, a bidirectional layer and a long short-term memory layer, or LSTM layer. You have the LSTM layer with embedding dimensions as the parameter. The layer actually serves as a parameter for a bidirectional layer. You essentially have a layer within a layer. Oftentimes, you will see two bidirectional LSTM layers in the RNN model. When this is the case, the first layer needs to add a parameter in the LSTM model to specify return sequences as true. This allows the model to pass the output values from each step to the next layer. Without this, only the last value is passed to the next layer. Bidirectional RNN models are good for analyzing unsupervised text-generating models. Recall in an earlier lesson you saw how supervised learning was used to tell the model if a review is positive or negative. With unsupervised learning, the model learns patterns of words with no particular sentiment or category associated with the text. In a text generation model, an input sequence is used as a starting point, and a bidirectional RNN model is used to predict what the next word is. This process is repeated for however many words are needed. The training data used as input for these models is considered unsupervised data because the model learns patterns of words without labels. The training data does not associate a sentiment or other category with the input text. Now it's your turn to play around with RNN models and discover the impact they can make.